All right, now we're going to try some examples with these properties of exponent problems that are based on using multiple properties together in the same problem. So they're a little more advanced. So in this first problem, we have 5x to the third power, y to the negative second power, all in parentheses, and then to the fourth power. So there's a few different strategies you could use to do this. A few different ways of going about the steps, but as long as you follow these rules, you should end up in the same place, no matter which route you go. The route I'm going to take is going to start by using this property right here. Since we have something with a power on it, with another power on it, I know I can multiply those exponents. But at the same time as I use that property, I'm also going to use this property that says when I have multiplication going on inside the parentheses, that power needs to apply to each part. So A gets the power and B gets the power. So as I look at this first problem, I see that this 4 is affecting everything inside this parentheses. So as I start thinking about it, that means that the 5 is going to have the fourth power on it, and the x to the third is going to have the fourth power on it, and the y to the negative 2 gets the fourth power on it. So I put the 4 on everything, and now using that other property I was mentioning earlier, the power of a power property, these ones that end up with 2 powers on it, remember the rule there says you can multiply those powers. So I'm going to have 5 to the fourth power, x to the 12th power, 3 times 4, and y to the negative 8th power. Now there's still a little more cleaning up we can do on that thing. 5 to the fourth power, that's just a number. 5 times 5 times 5 times 5. If you do that, you get a total of 625. X to the 12th, not much we can do with that. But then we got this y to the negative 8th power over here. Now since that's got a negative exponent on it, remember that means that we can turn it into division instead of multiplication. So instead of multiplying by y negative 8 times, I'm going to divide by y just 8 times. So that is this rule down here that we dealt with in negative exponents. When you have a negative exponent, it can move to the bottom of the fraction. So that's why the y to the 8th went down to the bottom. And that's all the more we can do to that problem to simplify it. So we're as far as we can take that one. Let's look at the second one here. Now this second problem has a lot of this going on, it looks like. Because I have numbers with the same base being multiplied together. Notice when I've got P and Q here, those are different bases, so I cannot use this property for those, but I can use it for the P and the P, putting those two together, and also for the Q and the Q to put those two together, so I can match up the variables. Now it also works that I could multiply this negative 4 times 2, since those are just numbers, so I may as well start with that. That would be negative 8. And then I'm going to put these p's together. P to the third times p to the negative 1. So since those are in parentheses are multiplied, so we're using this property here, that says add the exponents. So 3 plus negative 1 would be p squared. And then I go to my q's. Q to the 6th and q to the 4th makes q to the 10th. And that's really as far as we can go with that problem. Some people might wonder why I'm not moving this negative 8 to the bottom of the fraction like I did with this negative 8. Well, the difference here is this negative 8 was a negative exponent. This is a negative 8 as a coefficient. The negative 8 turning it into the reciprocal is only when the negative is on the exponent. So this negative is not part of an exponent, so it's just going to stay where it is. So that's as far as we can take that problem. Last one, we have a big old fraction there. So we're probably going to use this quotient property most of all. Now as I start looking at it, I can take it apart piece by piece and just look at the individual chunks. 5 over negative 20, those are just numbers. I can simplify those down. Let's let's see, 5 and 20 I can reduce by dividing by 5, so that turns into a 1 and a negative 4. So I'm going to come over here and write that. Now the A's, there's 4 on top and 1 on bottom. So this rule says we subtract those. This one does not have a power written on it, but we know that that means it's a 1. So 4, take away 1, leaves me with 3 A's. If you think about it in terms of writing them all out and crossing them out, we'd be able to cross out 1, and the 3 remainders would be on the top. So I'm going to put a to the third power on the top. Or another way to think about that is 4 minus 1 is positive 3. So we're multiplying by a 3 times, so we can leave that on top. Now B, a little bit trickier. With this B, we've got b to the negative 2 over b to the third power. Now, if I wanted to, I could use this property and say negative 2 minus 3. Subtract the exponents. That would give me b to the negative 5th power. So I'll put that up here for now. And then, oops, I meant to make this a negative 5 down there. So as I look at the C's, I've got negative 3 and negative 5. Well, if I think about that, negative 3 minus negative 5, remember we turn into adding the opposite. So that double negative turns into a plus. Negative 3 plus 5 is 2. So we're going to have C squared on top. Now we're almost done with this problem, except for that negative 5 exponent on the B. Remember, we don't like to have negative exponents if we can avoid it. So what we're going to do is use this property again, the one that says when you've got a negative exponent, you can turn it into a fraction. So this is already part of a fraction, but since this is on the top, what we're going to do with it is move it to the bottom. So I've got 1a to the third and c squared. And then on bottom, I'm going to have negative 4 and b to the 5th power. Became positive 5 as the exponent when I moved it to the bottom. That's one way to think about the problem. Another way might be to consider the negative exponents and move those first. Remember I said there was always more than one way to do these? Well, for some people it makes it easier if they think about moving those negative exponents so they don't have so many negatives to worry about. So if I do that, the first step would still be reducing the 5 with the negative 20. So I'd still have 1 over negative 4. Now I'm going to start thinking about what's happening to these letters here. A, right now those are all positive exponents, so I'm going to just leave those like they were for now. So a to the 4th and a on bottom. B's, well, I've got b to the 3rd on bottom, and b to the negative 2 can move down. Since it's a negative exponent, we can move that to the bottom of the fraction. So now I'm going to have both b to the 3rd and b squared down there. Now as far as the c's go, since both of these two are negative, we can flip-flop them. So the c to the 3rd is going to move to the bottom, and c to the negative 5th is going to move to the top. So I'll have c to the positive 5 on top, and c to the positive 3 on bottom. And now I can start to simplify these. So I'm going to have negative 1 over negative 4 still. Doesn't really matter which part gets the negative, but 1 over negative 4. Now I'm going to simplify the a's. So now we can still use that same rule that we were using earlier, just subtract the exponents. So 4 minus 1 would be 3. The b's, now that they're all on the same level, you can use this property that says when they're multiplied, we just add the exponents. So 3 and 2 make b to the 5th power. And then I look at my c's, and again, 5 minus 3, top minus bottom, would mean I have 2 c's on the top, so c squared goes up there. So you see we got the same exact answer, just two different ways of thinking through the process. Either one of those work, and there's probably a few others that we could have gotten there too as well. But that's just a couple of possibilities for how to work with these. Hope that helped.